All right. So here's a snapshot of what we're going to cover today. Uh, this is a pretty laid back presentation, so feel free to ask questions throughout our talk. You can use the chat, you can raise your hand, you can unmute. You're supposed to be able to unmute by hitting *6 or just clicking the unmute button if you're on a computer. And we are going to send a follow-up email with this recording, along with the project overview, resources, and our contact information. So we just like to start with who we are, in case we do have some new folks. And I know we do have some partners and longtime volunteers on the line, but in a nutshell, the St. Lawrence Eastern Lake Ontario Partnership for Regional Invasive Species Management, also known as SLILO PRISM, or sometimes we'll just say SLILO, is one of 8 PRISMs that span the state of New York. Creating a network of partnerships is an integrative approach to invasive species management. And the PRISM network is funded by the Environmental Protection Fund in coordination between the New York State Department of Environmental Conservation and various host organizations. And the boundaries of the SLILO PRISM include the 5 counties of Oneida, Oswego, Jefferson, Lewis, and part of St. Lawrence. And SLILO is hosted by the Nature Conservancy, and we collaborate with our regional and statewide partners to protect our lands and waters from the impacts of invasive species. We greatly appreciate your interest in assisting our biocontrol program, and we do have some other opportunities that you may also want to participate in. We'd like to encourage you to take our Pledge to Protect. If you haven't done so already, it's a great way for you to protect your favorite outdoor spaces from invasive species now and for generations to come. Upon signing up, you become a protector and receive a monthly email blog showcasing simple actions you can take throughout the year to prevent the spread of invasives or to manage invasives on your own property. In addition, you'll get access to virtual resource toolboxes and a social media toolkit, and you'll get chances to win prizes. We do have lots of other volunteer opportunities, such as water chestnut pulls, removal efforts, restoration projects, guided paddles, hikes, things like that. So those who are interested in volunteering with us can participate in our volunteer challenge, and you can earn prizes for your various participation. All of these opportunities are available on our website. And lastly, we'd just like to invite you to join us for a 3-part learning series to be held this spring and summer. This training is perfect for waterfront property owners, lake associations, kayaking groups, or just anybody who wants to learn more about aquatic invasive species. And participants will learn to recognize and report priority species and be invited to adopt a water body to monitor for species presence. And we do have continuing education credits available from the Society of Ecological Restoration and New York's Master Naturalist Program for those who attend this event or these events. And now I'd like to just give Robert the talking stick here to share more about the biocontrol program. I'm just going to have to give you access. There you go, Robert. You should be able to take it away from here.
Perfect. Thank you, Megan. And good afternoon, everybody. And before I start anything, I really want to thank you. I appreciate you all wanting to volunteer for this. This is a super important project that we're doing. The project is going to determine whether the EAB biocontrol insects we've been releasing the last 2 years are establishing a population. And why is that important? Well, that's important because if they are, then we now have predators out there that are targeting emerald ash borer, and that's going to help keep the population of emerald ash borer down and save a whole lot of ash trees out there. So this is such an important project, and I'm glad that you all want to participate. All right, little background. The USDA's EAB Biocontrol Release Program involves 2 years of releasing the EAB parasitoid wasps, followed by 2 years of conducting establishment surveys. In 2022 and 2023, we completed the releases of the biocontrolled insects at Rice Creek Field Station. There was 3 different kinds of species that we released. You can see it on the slide: Spatheus gallinae, Tetrachicus planopenisi, and Ubius agrilli. And you can see the numbers of each one that we released for a total of 10,199. The second 2 years, which we'll be conducting establishment surveys, is starting this year. So we'll be doing the surveys both this year and the following year. All right. I'd like to talk a little bit now about each of the parasitoid wasps that we released in the last 2 years. The first one I want to talk about is Ubius agrilli. The Ubius agrilli targets the inside of the EAB egg. So it will inject its own eggs inside the EAB eggs, which you can see right there in the picture. The larvae will emerge from their eggs inside the EAB egg, and they'll feed on the EAB embryo, and they'll end up killing the egg. There's at least 2 generations that are produced each year, and this species of parasite wasp will overwinter as a larvae in the EAB and emerge as an adult in the spring. Ubius agrilli parasitizes up to 60% of EAB eggs laid during the summer, and in some areas of China, during the summer in some areas of China. Each of the Ubius adults parasitizes up to 80 EAB eggs during its lifetime. So that's a pretty good ratio there, 1 to 80 ratio on that. All right, moving on to Spatheus gallinae. It targets the EAB larvae by paralyzing it and laying about 8 eggs on the outside of the host. The larvae will emerge, feed, grow, and it will kill the EAB larvae. They're known as ectoparasitoids. There's 1 or 2 generations that are produced each year. This species of parasite wasp will overwinter as larvae or pupae and will emerge as adults in the summer. Spatheus gallinae is actually the newest of the EAB parasitoids that USDA was approved for release. It was approved in 2015. It fills an important niche in that it's a long ovipositor, and that's what actually releases the eggs. Since it's so long, it allows it to parasitize EAB larvae in large diameter ash trees up to 23 inches in DBH, which is something that's difficult for any of the wasps with a longer or a shorter ovipositor. And the last one that we released is Tetrachicus planopenisi. The Tetrachicus planopenisi targets EAB larvae by laying its eggs inside of it. The larvae will emerge from the eggs, they'll feed, grow, and they'll kill the EAB larvae. These, parasite wasps are known as endoparasitoids. One of these EAB larvae can produce up to 130 Tetrachicus adults, and there are several generations that are produced each year. This species of parasite wasp overwinters as a larvae in the host or as a prepupae in the host gallery. They will pupate and emerge as adults in the spring. All right, the itinerary. Oops. All right, the itinerary. This is what we will be looking at doing this summer. Every Wednesday, we will conduct this survey at 10 a.m. from June through September. We'll meet right in front of Rice Creek Field Station building. Once we all gather up at the building, we'll all then move on to the blue and orange trails. They're the yellow pan traps. There'll be 15 yellow pan traps, and you'll see a little map of it later on. Are relatively close to the trail, and we've actually cleared paths, which to the where the yellow pan traps are going to be set up, which was best for for all of you that are going in to help on this, because it's that whole area is full of multiflora rose. If you're familiar with that, like any other rose, it is lots and lots of thorns. But we're going to save you the pain and trouble on that, by clearing all the pathways to those yellow pan traps. Once we make it to the yellow pan traps, we'll collect the samples from the traps, and then we'll take those samples to Rice Creek Field Station lab. We'll sort through those samples using microscopes. Any insects that we find that we suspect are the EAB biocontrolled insects, we'll put those in a vial, and then the vials will be stored in a refrigerator, and then we'll send those vials out to the USDA lab in Massachusetts every month. So if we have, so each month basically we'll have one sample for each, or one vial for each week. So 4 or 5 samples will go out to the USDA lab for verification. We're not going to identify these 100% correct. I'm not expecting you to do that. I'm not an entomologist, and I know, I'm assuming most of you are not entomologists. So what we're going to end up doing is we're going to identify them as best we can, place those that we think are the parasitoid wasps that were released into a vial, send the vial to a entomologist, at a USDA lab, and they will then look at those, and they'll let me know whether we found something or not, and I will in turn let you know. Weekly emails will be sent to confirm your attendance. So we'll send you out an email on Monday which will ask you, are you going to attend or you're not going to attend? That way I have some sense of how many people will actually be there on Wednesdays. Yellow pan traps. All right, so how does yellow pan traps work? If you look here at the picture, right, you'll see basically a bowl that looks like you could buy it at like Dollar General or something like that. And that's basically what it is. But the thing is that the color is what is the lure in a yellow pan trap. Many species of adult bees and wasps are attracted to the color yellow. And this includes the EAB parasitoid wasps, those 3 species I was just talking about that were released at Rice Creek Field Station. Also some native naturalized parasitoid wasps, like Atanicolis, some native Spathius, Asgonophora, Saccata, and Balca indica. Which you might ask yourself, it's like, if those are parasitoid wasps, why do we need to release the ones that we just released? Well, the ones that we just released are specific. They target only EAB. These native naturalized parasitoid wasps, they're not as effective. They're not as high impact because they attack many different other insects, including EAB. But they are attracted to yellow. So basically that's the lure for the trap. Inside the bowl is mostly a 20% solution of propylene glycol and just a dab of dish soap. And they're both clear. So basically the insect goes into there, gets attracted by the yellow bowl, does not see the liquid in the bowl, flies down into the liquid. The dish soap actually weakens the surface tension of the liquid. So the insects then plunge into it like a person diving into a pool. And the propylene glycol, they'll just drown in it. All right. So where are we setting up the traps? All right, we plan to set up these traps on 15 ash trees. According to the USDA's recommendations. Those recommendations include placing them on the southwest or west side of the trees and along forest edge. So relatively close to the trail system that surrounds the release area. And you can see right there in the picture on the right, all the little triangles are where the yellow pan traps will be set up. And you can see the trail is very close to where these traps are set up. So very forest, that's about as close along the trail as forest edge as you're gonna get. We also have a couple fields, if you see there in the lighter green. So those are optimal because they're definitely forest edge areas. Oh, for the Ubius grilli, they recommend ash trees with fresh woodpecker damage and less than 30% dieback. While for Spathius gallinae and Tritascus planpanisi, they state that higher dieback up to 80-90% is fine. So most of the trees that I have selected have less than 30% dieback. That way they'll attract all three species. They also most of them have woodpecker damage to attract the Ubius. All right, when and how to collect. We will be checking each trap once a week. Each visit will involve pouring the contents of the trap through a paint filter, which you can see down on both those pictures. You can see the paint filter there. We'll also have a squirt bottle that we'll use to dislodge any insects that get stuck in a bowl. The open end of the paint filter will be folded over and placed into a labeled Ziploc bag, just like in the picture. The trap will then be refilled with a few drops of dish soap and 20% propylene glycol solution. On hot days, it's recommended that the collected filter samples will be stored in a cooler with ice packs when transported. So I might come out some days that are really hot with a cooler. The samples can be stored in a refrigerator if we're going to process them for it's going to take us a couple days to process them, or longer than that. We can put them in a freezer, but we plan on doing these same day. So once we get them back, and I'll go into this in a minute, we will be processing. We won't put them in the refrigerator and store them. All right, processing insects from the yellow pan traps. All insects, oh, sorry. Once in the lab, the insects will be removed from the paint filters, and they'll be placed on a petri dish. Some alcohol will be added to help break up the samples, and then sorting for the EAB parasite wasp will occur using a microscope at the lowest magnification. Those insects you think look similar enough to the parasitoid wasp will be further examined using a higher magnification. All insects suspected of being an EAB parasitoid wasp will be placed in a vial with 95% ethanol. Paper label will be placed in the vial that's written in pencil, the site name and the date. The vials will be stored in a refrigerator until shipped to the USDA lab for positive identification, which I mentioned earlier will be done monthly. The alcohol will, just before we ship it, will be poured out prior to doing the overnight shipment because the postal regulations don't allow us to actually have alcohol in the vials. All right, EAB parasitoid wasp identification. All species, including species Gallinae, the one we're looking for, have bodies that are reddish brown, except for the abdomen, which is a dark brown or black. These wings have brown veins, and their forewings are tinged brown with clear band areas. The hind wings are clear, but they still have brown veins, and you can see that lower right picture there where the hind wing is. It's all clear, but except for the brown veins. Their heads are spherical, and their antennae are very long. And if you zoom in with your microscope, you'll see it's over 26 segments on the antennae. And they're about 1.2 times the length of the body, not to include the ovipositor. All right, Spacius gallinae. Spacius gallinae's body is also reddish brown with a dark brown or black abdomen, as all species in the genus Spacius, like we just talked about. The wings of Spacius gallinae have spotted clear areas rather than a distinct stripe. So if you see there's other ones like Spacius grilli, which doesn't overwinter, can't overwinter here. It's it's just not cold hardy. You'll actually see like clear stripes on the wings, but with Spacius gallinae, you'll just see these little spots of clear areas. The ovipositor is long relative to the size of the body, and the base of the tibia of all the legs is yellowish, which you can see in the bottom left photo. That should be a pretty good key characteristic to use. The back of the head is smooth and wrinkle-free, which you can see in the bottom right picture. And that's different than some of the other Spacius species, which have wrinkles. All right, here comes the fun part. There are a whole lot of Spacius lookalikes. So how are we going to deal with these Spacius lookalikes? Well, we'll try to find characteristics on these lookalike insects that just don't match up with Spacius gallinae. So this guy right here, and I don't know the specific species that these different lookalikes are, but I can tell you that it's not Spacius gallinae because the antennae are too short. The wing pattern doesn't have those little spotted clear patches like I just talked about, so that's all wrong. And that ovipositor is way too short. This insect does not have a spherical head. It's more oval shaped. Also, if you look at the femur of the leg, which there's an arrow pointing towards it, it's also large or swollen in appearance, and that's just not typical of Spacius. The antennae are also much shorter than what you see in Spacius, so we can eliminate that guy. All right, on this one, the wings on this one are clear, not brown tinged, with clear spotted areas, and its body is more yellow than brown. All right, next I want to talk about Certasticus planopenisi. This is another one of our parasitoid wasps that was released at Rice Creek Field Station. It has red to dark red eyes. The females have a taper shape, as you can see in that top picture, with a narrowing abdomen. The final segment of the female's abdomen is uniquely long. It's about 4 times as long as it is wide at the base. The female abdomen is actually longer than the thorax, as you can see in the picture. Both the sexes have 2 longitudinal grooves on the middle thoracic segment. You see on the bottom left photo. It also has a dark femur, and they have clear wings, which little tiny specks of dark, but mostly clear wings. On the top right picture, you can see those long eyelash like hairs, also known as setae. The Trichescus planopenisi also has a long terminal segment, which can be seen in the lower left picture, and a smooth dark thorax, which you can see on the right side. All right, I'm not going to go into all the little details here. You can read them if you'd like. I just wanted to point out that the male and female antennae have 6 or 7 segments. The female has 6 and the male has 7. So that's one thing you want to look for is, does the insect that you're looking at have 6 or 7 segments to their antennae? If they have less or more, then you can eliminate that one, push him to the side. He's not a Trichescus planopenisi. All right, just like we were talking about before with the Spatheus, the Trichescus have many lookalikes. This insect here, the antennae are too short, so you can eliminate it as Trichescus. Insect on the left has antennae hairs that point out in all directions, so it's too spiny to be a Trichescus. The insect on the right has a clear femur, and the hairs stick out. They're not curled, like an eyelash like hair that's seen on Trichescus. And this insect, the setae are way too long, so we know it's not Trichescus. All right, on this one, the abdominal section, a segment of this insect is way too short with Trichescus, which has a much elongated abdominal section. All right, this slide right here demonstrates the amount of Trichescus lookalikes you may see in a single sample, and that's a lot. So you're going to have to be dealing with a lot of these confusing insects to sort out. So what you need to do is find some of those characteristics I was talking about before, like wrong antennae, wrong thorax, wrong legs, wrong wings, to eliminate some of these insects. At the end, you might still have 1 or 2 that you're not sure of. And you can have me take a look at them. If I'm think that they could be the Trichescus, their planopenisi, we will put them in the vial. Oh, we're also going to have a guide for you, by the way. So we'll have a guide. They'll be located by each one of the microscopes in the lab. And I also have, see here, I also have samples that the USDA sent me of each one of the species, and I'll put a few of them in a Petri dish so that you can compare them under the microscope with the samples that you're going through. All right, after you're done sorting out the samples, like I said earlier, show me what you believe to be the one of the parasitoid wasps that we released. If I think it could be, I will place them in a vial. So just remember, when in doubt, send it out. And our last parasitoid wasp that we released is Ubius agrilli. Ubius agrilli released for the EAB biocontrolled are all parthenogenic females. That is, they do not need to mate and only produce daughters. The adults are very, very small, around 1 millimeter long. They have compact, stout bodies with no waist and a visible short ovipositor. And their body color is black to a dark brown, and they also have a kind of a bluish green sheen and reddish eyes. All right, the segment on the antennae before the club clava is clear or yellow. You can see that in the picture in the upper left, while the other segments are darker. So that's definitely a key characteristic that I know I will be looking for, and I recommend that you look for it as well. The picture on the right is known in entomology as a tarsus. But that's basically just a foot. So that's what they call it in etymology terms. So that's the foot of Obius agrilli. It has 4 tarsal segments, which you can see there. That's a good key characteristic because all known native species of Obius have 5 tarsal segments. So if you see 5 tarsal segments on what you think is Obius agrilli, you can eliminate it. Because it will never have 5 tarsal segments. The antennae of Ubius agrilli have 9 segments, which you can see right there, and they're listed off into different sections. The clava is distinctly clubbed. And see the upper left, it's the last segment of the antennae. So, also the antennae is elbowed, or genticulate, if you want to break out the entomology terms. Oh, I wanted to just put this out here, and I'll have a few of these out at the lab too, because I know we use some of these entomology terms there, and it's I want you to be able to connect the pieces. So I just with the leg, you can see the bottom portion is a tarsus, which is really the foot, and then you have the tibia, which then goes to the femur, and those are really the 3 same sections that you'll hear are you'll see in the guide for different ones of the insects. Oh, also, you may see a few native or naturalized EAB biocontrol insects, in your sample. These are a few native Tanacolis species that you may encounter. They're all large with a distinct red or orange abdomen, which you can see right there. In contrast, the head and thorax are jet black. So that's really, that's not, you shouldn't confuse that with one of our parasitoid wasps, but you might see these in your sample. The Phasgonophora sulcata is a native solitary endoparasitoid of EAB that has a red orange section of the abdomen. All right, Belka indica is naturalized in the eastern U.S. It's originally native to Southeast Asia. It's a ectoparasitoid of EAB, and I mentioned these earlier before. They're not specific to EAB, so they might do a little bit of help out there with EAB, but they won't target them in enough numbers to control the populations. You may also find native Agrilis species, which is the same genus as EAB. One species is Agrilis subcinctus. It looks like EAB, but is smaller and brown, and it feeds on recently dead ash trees. So that's one of the reasons why you might see it in your sample, because we have some trees that are, dead or dying out there, and these Agrilis might have already moved in. All right, just a few helpful tips. When you're processing the yellow pan trap samples, you'll find a lot of debris. Insects often get stuck to this debris, so you'll have to check all of this debris for potential parasitoid wasps. Whether you check all the debris at once or a little bit at a time, it's really up to you, as long as it's all checked. Oh, we have I mentioned already, we have sample parasitoid wasps that you can look at the labs. But make sure you're comparing them at the same magnification. So I'll have a microscope set up with the samples, and make sure your magnification there, when you're comparing the suspected one with the sample one, that we're looking, at the same magnification. Otherwise, you might easily confuse the two as being the same. All right, in this photo, you can see the size difference of EAB, Ubrius agrilli, and Toshascus planopenisi. This is a word of caution. Do not rely on the size alone, since this can vary depending upon clutch size and the size of its host. All right, recommended equipment. The area where the yellow pan traps are located has a lot of multiflora rose, which is an invasive rose species. This means there are a lot of thorns around the traps. And even though I've tried to keep the traps relatively close to the trail and cleared a path to the traps, you should still be prepared for walking through areas that have plants with thorns and sometimes mucky conditions, especially right now. Hopefully it'll start to get drier. But if you've been out to the Rice Creek Field Station on the trails right now, there's mucky areas right on the trails. That gets better as the months go on. But especially now, I would recommend that you have some kind of boots there. Don't go out there with sneakers or flip-flops. You need, some kind of boots there to keep your feet both protected from thorns and sticks and what have you, but also the wet, mucky conditions that are out there. I see. It is recommended that everyone wear pants, preferably some pants that have some resistance to thorns that don't easily tear. I personally like to wear jeans, but if you have any kind of pants that will help you with the thorns, I recommend. You may also want to wear a shirt with sleeves, although this can be difficult during the summer months when it gets really hot. I mentioned we'll be walking in off trail areas, so that means uneven ground, moist areas, and I already mentioned boots to protect your feet. Our surveys are time sensitive, and what's that mean? It means that we need to collect the samples rain or shine. There's no rain dates with this. So if rain is a possibility for that day, please bring some kind of rain gear to prevent getting soaked. Oh, I also expect some of the days out there to be quite hot. So bring some water. Bring plenty of water to avoid dehydrating. We don't want anybody getting dehydrated out there. Also, if you happen to have thorn resistant overalls, which might be a little bit too much on these hot summer days, but if you happen to have thorn resistant overalls and want to use them, you're welcome to do so. I actually have a pair I used in the fall when it was cool, and they worked fantastic. All right, next steps, Megan's gonna go over that portion, so, thank you, very much for the time. I'll take some questions right after, Megan's, done with her section.
Great, thanks, Robert. So some of this is a little bit of a repeat, but just want to reiterate some things. So starting Monday, June 3rd, you'll be receiving an email. Just look for that email and it's just going to be, respond whether or not you're going to be able to join us for that first survey on the 5th. And every Monday moving forward, you'll receive the same email and you just respond accordingly. And within that email will also be a calendar invite for the entire series. So all of the Wednesdays from now until September 25th will be in that calendar invite. Just accept it so it can be added to your digital calendar. If you don't use a digital calendar, that's fine. Just, note it anyway. That will help you remember the dates. And as mentioned, our first survey will be Wednesday, June 5th, 10 a.m. at the Rice Creek Field Station. And this is Robert's phone number. It will also be in the email, so you'll have it noted. But just give him a ring or a text or something if you said you're going to come, but you can't come for whatever reason. And also just note your time as well. We do collect volunteer hours, like try to quantify the efforts of our volunteers. You can just note it somewhere on paper or maybe in a phone note. And we do have a log that's online. A link will be given to you and you can report your time to that log as well. You can report, each time you go out, or you can, maybe wait a couple weeks and report multiple times in one submission. Just as long as I do get your time there. And also, we do have some liability waiver forms that we'll ask you to sign. I'm gonna try to see if I can get my Adobe publisher to work and send them out digitally for you to sign. But if I can't get that to work, we'll have some paper forms for you to sign. You just need to do it one time. So we'll have those for you as well. All right, and now it's just open discussion. If anybody has any questions or comments, feel free to come off mute or utilize the chat area if you can't talk, and we'll take questions now. Or maybe we just did a really good job explaining everything, so you don't have any questions, which is fine too.
Well, I'd like to add there, that, we're trying to make this as fun and as high quality of a learning experience as possible. That's why it's like, and because we understand that, you come with various levels of experience at this. So that's why we have a guide that we've done up. That's why we bring it there. I requested the samples from the USDA lab, which they, generously sent me. And why we're clearing the paths, because we spent the last 2 summers randomly selecting trees through all that multiflora rows, and it's painful. Just be blunt about that. So we're sparing you all of the thorns. So I've already cleared 8 out of the 15 spots. I'm clearing 7 more tomorrow. So you'll actually have a nice little like a trail. So you just walk straight down the trail to the pan trap, dump the pan trap there into into the paint filter, put the paint filter in the bag, move on to the next yellow pan trap. So, we're trying to make this a fun experience that we hope you all enjoy.
Okay, well, if there's no questions, that concludes our training. And Lucas, are the yellow pan traps recommended for homeowners who own ash wooded property? The director of Utica Zoo was interested in setting some up at the nature preserve at Beaver Sprite.
The paint traps are going to collect various, insects like like I was talking about earlier. If you're close to where there's a release, it's like and like I know SUNY Oswego, I believe, might, has done one pan trap there outside the area. But yeah, I mean, if you don't have parasitoid wasps, it's not really gonna, be beneficial to there, because you're not really gonna collect you're not gonna collect anything that of, of value, with it. So, I mean, it's more for research than it is for a homeowner.
And I would like to just note that we will have some thank you gifts available for folks as well for joining us too. So we have some pretty cool stuff that we're going to be giving you as a thank you. All right, well, that concludes our presentation today. You're welcome to email Robert or myself, and just I'll be sending that follow-up email very shortly as well. Have a great day, and thanks again for your help.
Thank you.
Yes,
Bye.
yes, thank you.